Hey, how we doing? Last minute technical issues, as always. Gotta love the last minute technical issues. Dear oh dear. So I've got my camera down for some reason today. Never mind. So I'm talking to the webcam today. So hopefully that picture's okay. Let me just get my chat because I am a little bit behind as usual. I've got to look around my camera now. That's better. I'll get you over this side. I'll be able to see what we're up to. Oh dear. Right. Crunching noises again, apparently. Yes, gee, it could be that. Okay. Looks like I've got the USB microphone on as well. Crackle, crackle. Is it bad, is it, Nick? Ah, don't say that. Yeah, okay, I'm going to have to swap microphones as well. Bear with me, just to add a different microphone into the situation. So we're a camera down and a microphone down so far. That's a pretty good start, isn't it, really? Oh dear. Right, let's have a look. Where's my Yeti? Yeti, there we are. We'll mute that in the headphones. Hit OK. Let me mute this microphone a minute. And go on to the Yeti. How's that? It's probably totally out of sync, but looks like that's what we're going to have to put up with. I'm going to have to take this microphone apart again and redo the connection. What a pain. So is that okay now? It's sort of under the desk, the microphone, so it's not ideal to be fair, but I can put it back up on top in a minute. Any feedback on whether the microphone's okay? A bit quiet. Okay, no problem. It's no problem. So let me see if I can find the microphone. Let's pump it up a bit. So yeah, it's a bit quiet because it's underneath the desk. But I should be able to increase that a little bit. Yeah, it'll be fine if I stick it up on the desk, but so device volume, let's chuck it up to full whack and let's pop the gain up a bit. No. Hopefully, I mean that's peaking quite loud now, so that should be okay. That should be okay. Sync is okay. Well, that's good. That's good. Well, I can see it's peaking right up on top of the screen now, so that must be loud. Needs cleaning now. It's the wire. Unfortunately, it's the way that it's made, but there you go. Where is the old volume button? Afternoon, Arthur, how are you? Yeah, there's no volume button on here. It's all sliders and all sorts of weird and wonderful stuff, Arthur. I've got an audio mixer, virtual audio mixer desk over here. So hopefully that's loud. Any feedback? Help, come on, tell me. Is it loud? Too quiet? Do I need to stick it up on the desk? Let's turn that microphone off and get rid of it out of the way. Volume level's okay now, excellent. Okay. I'll just put some of this bits and pieces out the way. As I say, this is just the webcam today. For some reason, the SLR camera's decided it doesn't want to connect today. It's probably because I've been messing about with the outputs for connecting the Amiga up to it. Got some background noise. I can't win, can I? Okay. It's because I got the gain turned up too high. Okay. Audio microphone. Well, I haven't got the gain turned up that high. Compressor. Stick the compressor on. And we'll stick the noise gate on. Right, so that should be silent in between, hopefully. I think we're gonna need to put up with that. I think I can't monitor it, unfortunately, because I've got no headphones set up here. So just no, I won't mess with it too much because it'll blow your ears off if I start messing about with it. Can we get on? Sounds low there again, Rob, is it? It is lower, yeah. Let me stick the mic up on the desk. That's going to be the best bet. So let me make a bit of room a minute. Bear with me because there will be some noise as I alter all this stuff around. The mic is underneath my laptop bench at the moment, Benji, but it's coming out. So don't you worry yourself with it. Let me worry about that. So I'm just making some space. There he is. Right, let me see what mode it's in. Yeah, it's in the right mode. So that's probably better now. Well, hopefully it is. Still got Christmas deck on the door. No, that's not. Yes, it is. Well spotted, Rob. Yes, Mrs. Cruncher's done a bit of a shave-up job. Right, okay, let me just get back up to the start here. So I was in first today. I'll beat all of you. So we've got Rob Titheridge in, Michael Hyde, Barry Charnley, Colin Parnell, Dennis Bargetzi is in, Nick Petronics, Rob Cross, Benji's there, Simon's World. It would be good if you could build a PS into an empty PP9 battery like the hacker did with the P18. That would be very good, Simon, wouldn't it? That would be very good. Afternoon, Doug and Douglas James. Doug and Doug. Who else have we had in after since that? Arthur's in. Afternoon, Arthur. Rob Hall spotted the decks. Dids. Yeah, she's giving me a good old lump up. I expect the noise you were hearing before was the fan on the laptop. I expect, being that the microphone was directly underneath the laptop. I mean, I do like this mic, to be fair. It's really nice, but it's just not as practical as the wireless mic because it's stuck there. I can't walk about with it. But we are going to be looking pretty much on the bench today, so the only other issue I've got is that probably the top of the mic's going to come into shot a little bit. Let me just see if I can pull it out of shot. Well, that's a bit better. Okay. Paul, you're on silent in the background. Can't join in. Busy doing the teacher thing with Junior. Should be interesting build though. Ping on my Facebook. Cheers, Paul. Thanks for that. We're on a go slow again today. My internet's struggling. I've got too many windows open here. That's the problem. Let's close down some of these windows. We don't want to close that one because that will knock us off the stream. AliExpress, we don't need that. Photos, my drive. Okay. That should be better. So Paul sent me a schematic. It looks like a transformerless. Yeah, that's interesting, Paul. Paul's just sent me this schematic. It looks fairly straightforward. We've obviously got a Zener diode there, D3. 4739A. So we got, is that half-wave rectifier? 2 1N4007s. So we got a capacitor and a resistor in parallel. 220 volts on the input. Interesting. That's an interesting one to build. I've got this C1 though. Would that be a mains rated cap? Because this is all rectified after here, isn't it? And that's obviously clamping the voltage down to 9 volts. But 0.47 electrolytic. Yeah, not sure on that. Thanks for that, Paul. But I'm not 100% sure on that. What I was going to try and do is build some stuff from bits and pieces. Afternoon, Buzz, how are you? Yeah, did complete an SMD practice board last night. Got it from Amazon. What a soldering challenge that was. Afternoon, Harvey. No, don't use that. Not recommended. No mains isolation. Yeah, it does look a bit scary, but I can see Paul's point. I mean, it's transformerless, so it'd be a lot less cost. So I've got a couple bits on the bench. First of all, I thought we'd have a quick look at the R707, which I've just finished. So let's go over to the main camera and let me try and zoom you in. So yeah, the R707 is actually done and dusted. I had some issues with it because the my picture, I got the webcam in the way of the screen, the output screen. Afternoon, Phil Taylor, how are you? Phil the power. So I had issues with this. I finished it all done and dusted, and all of a sudden it decided it wasn't going to work on shortwave. So I did a lot of head scratching and looking at the schematic, discussing it with people, and what I did in the end was I ohmed out between the VHF module and there's a capacitor that goes into the IF module, and that was shown as open circuit, that line, whereas it's formed by 3 of the different switches all making contact. So luckily it was just a problem with the switches, but as I say, it's all done now. It's looking rather spanking. So we'll quickly chuck some batteries in it. As you know, this uses these weird, is it P996 or 966? I mean, this says it's a 4R 25R, and this one is a PJ996. So it's a 4R25 or it's a PJ996, and they'll only go one way round. So it's usually with the positive at the lower edge. A lot of people struggle with this, and a lot of people have had these radios and said there's a problem. There's the batteries are missing. The battery connections are missing. Yeah. So let's have it on then. Let's stick the aerial up. Aerial's all been lubricated. Let's go VHF, AFC.
Cause I hate to find articles, rather you remain unremarkable.
But if you live in a cramped one-bedroom flat, then you can't.
Yes, the issue is very real. We've actually seen for some period of time that the inequalities that exist generally in activity levels are pretty...
I thought the big oaf might fall flat on his face. I'm not going to say I was looking forward to it, but I really did draw up a chair and think, oh, this will be good. Yeah, he's quite good at it.
Have you seen the guys recently?
Yeah, because we've been planning stuff.
Medium wave. As usual, picking up absolutely masses of interference.
I wonder if they, defense is so good for United now that.
Long wave, radio 4 is about all we're going to get there.
With girls doing more exercise now, because it's often
It's probably my scope.
How
Let's unplug that.
the school environment can be off-putting.
Turn that
for
off.
some young women exercising in school.
No,
And
still
actually,
do it.
the
It's
evidence
this light here, I
last
bet.
year bears that out,
Yeah.
in that probably the biggest single impacted element of children and young people's activity was boys' team sports, which saw a significant drop-off, and because.
And shortwave, I mean, you can hear it's working, but it's the wrong time of day, really, for shortwave. Shortwave is best done in the evening. Let's see if we can stick that down the aerial hub. There's something there. Where's that? 49 meters.
A, 16 Grad Ost, senkrechte Polarisierung auf der Frequenz 11,512 Megahertz, Symbolrate 29,95.
There you are. So that's the R707 all back together and all working. I'm still on camera, yeah I am. I've got to move that across, it's a flippin' annoying. Let's just move that this way a little bit. There we go. Simon, Mr. Spires, how are you? It's a no. How to turn your radio into live chassis? Hi Michael Stevens, how are you? Number station. It did sound a bit like that, didn't it, Nick? But no, it's Radio Romania International, that is. That's a very so this wire is not a great connection. There you are. Yeah, so that's the station ID for Radio Romania International, I believe. Yeah, I think you're right, Doug. It was certainly German speaking. So there you are. That's the R707. Which will be off to its new owner hopefully tomorrow. I've just been sort of giving it a bit of a test out over the last couple of days just to make sure everything's all okay. So, other things then. I've got some things. I've got a transformer. I've got a plug. I've got a breadboard. I've got some jumper wires. And some crimp connectors. So I've also got this other transformer. Now I believe this one was doing about 10 volts out, I think, wasn't it? So we could whip this transformer out and have a play, or just use it as it is and just pull the outputs out of it. I mean, this is a pretty hefty transformer. It's way overkill. It's got two 12-volt outlets, so it'll do 9 volts and 12 volts. But I think Chris was saying if we connect it in series, I think he said it will give us something like 36 volts. So it's really a case of just connecting this up. I'll pop it into the inlet of the power of the breadboard, and then we can start perhaps looking at laying stuff out and trying to see what it's doing. I've got bridge rectifiers. I've only got I've got a variable regulator, and I've got 5-volt regulators. So I'm really not sure which way to go with this. But I just thought we'd connect it up and have a play. Afternoon, Jess. How are you? Can you pick up the speaking clock on shortwave? I don't know. What's the frequency of it, Jess? So we need to connect this up to the mains first. I've got my isolation transformer down there. This is going to be a mains supply on the bench, so we've got to be careful. I mean, it's designed to go in an enclosure, really, because the terminals are able to be touched. Even if I insulate that end, we've still got live up the top here, which is not great. I'd have thought they would have encapsulated that, really. But so, or we can just mess about with this one, which is a much smaller transformer. But Nick very kindly sent me over what circuit am I using. I really don't know at the moment, Harvey. We're just experimenting at the moment. Nick sent me a circuit earlier. Let me see if I can get that up on the screen a minute. Nick sent me a circuit on Messenger earlier. Oh, I'll tell you what, this is running so slow. Hopefully my internet's holding up, because this is really slow today. Victor's saying he can't watch the stream because he's at work. I can't read the screen now because I'm working my way around this camera. God. Let me just show you the schematic that Nick drew me out this morning. It's really straightforward. Okay. But say my idea really was to just have a look, see what bits and pieces I've got, and just go through, see what we can make. I've got Zener diodes, plenty of Zener diodes in here. I've only got 2 core, but there's no ground on this, so I will have it attached via my. So that would be an ideal situation. I haven't got a 7809 or a 7812. I've only got a 7805, I believe. So certainly we can do the first part of it into the bridge rectifier, and then we can have a look at the output from the bridge rectifier. I've certainly got 470 microfarads or higher, and I've got the 0.1 microfarads. I have got this adjustable regulator as well, which we can look at. So let me just grab a bit of heat shrink a minute. I'm just going to put you back onto the bench. But that's a great little circuit. I mean, it doesn't need to be anything fantastic. It's only powering a transistor radio. It's not going to be high current draw. It's going to be pretty straightforward, hopefully. You could use cascaded 78 series regulator for multiple voltage output. Okay, Jess is saying is it exactly on those frequencies? Exactly 5 megs? Exactly 10 megs? Yeah. Right, let's get some water going here because I got a bit of a dry throat. So I think what I'll do is I'll just solder these to the terminals for now of this. I'll chuck a bit of heat shrink on it because I don't like them exposed like that. So bear with me. Let's get my heat shrink as well. Probably too big. And this is probably too small. That may work. I'm severely short on heat shrink at the moment. Of any decent sort of size, that'll do. A bit of white. But I will tape this up as well, just to stop myself getting a shock, really. I think what we were looking to do, is to build just one power supply of each voltage. I mean, I've got one of these adjustable ones, which is, let me see, what bin number was it? Number 12. So I've got these, which are let's get the overhead camera on here as well. We do have a camera shortage today, but hopefully we can make do. Whoa, too big. So I've got these. These are an SMD device. I can't remember. I bought these in to fix something. I can't remember what it was now. If I can get the plugs at the end of the blimmin' things. Now these are LM. These are in quite a hefty package. It's LM 317S. Afternoon, David. How are you? Make my own coil? Dids, what are you on about? Yeah, so LM 317S. That's one, and the other ones I've got are these ones here, which are also LM 317s. And according to the little piece that I put in there, they're 1.2 volts to 37 volts adjustable. So it might be worth using those. I'm assuming that one of these is going to dissipate more power than one of those. I mean, put them side by side, if I can get them underneath the camera even. It's a big difference in size, so I mean that's got to be able to dissipate more, but it is an SMD device. It's not really suitable for what we're trying to do here. So I think potentially that could be something to go for. That would give us a bit more scope. So who was saying? Well, Rob was saying if you use that circuit, I would use the small TX. The new one you have is for using center tap as 0 volts and 2 diodes for full wave rectification. Right. Well, I mean, Nick's diagram has got a full wave bridge on it. I was just thinking of maybe using just the 0 and 12 volt output rather than using all four, Rob. So the LM 317, let me, if I just put that down on that component. Let's just go back to the bench a minute. Yeah, well, that was a nice little sketch. I mean, I really didn't know what. So this is an LM 317 LZ. So let's get the sheet. Get the sheet up for this. I'm gonna have to move that webcam. I can't work with that stuck in front of the computer. That's a nightmare. Apologies for the whacking of the microphone. There, hopefully you can see me now. Okay. So it's a 3-terminal adjustable positive voltage. Now I can't remember how they adjust these. Do they adjust them with resistors? We'll see in a minute. So adjustable between 1.2 volt and 37 volt. So the LZ is a TO92 package. Okay, they're all the same device then, pretty much. So pin 1 is the adjustable voltage, pin 3 is the input, and pin 2 is the output. Let's see if I can get your chat up as well at the same time. Just get that down a little bit smaller. I see what you're saying, Nick. I think the only 778 series one I've got is a 7805. So that would only give us 5 volts out, wouldn't it? So Harvey said, don't forget 100 NF caps from the negative to both sides of the regulator. It should give us an example circuit here. I was just wondering whether this is it should give us an example. Here we go. Okay, so this is slow turn on, electronic shutdown, current regulator, 5-volt electronic shutdown regulator. Yeah. So they're using a variable pot on this one. Slow turn on regulator. KSP 2907. I've got absolutely no chance of having one of those. Yeah, there's not a lot. There's not a lot I'm going to be able to do on that. I don't think. I've probably got the diodes. 4002. I've got those. I think I've obviously got the 317. I've probably got the resistors, but I haven't got this here. TTL control. So this is that's no good. This is probably more like we want the slow turn on regulator. Afternoon, Derek, how are you? That circuit is hopeless. You don't need a transistor. I wonder why they got the transistor in it then. Let's see if I can do LM317 power supply schematic. That looks easier. 2N3055. Now that is something I might have. The 3055. That's the yeah, I have got loads of those. I think that's the one in the big can, isn't it? The TO, whatever they call it. I say I've got loads of those. I can't really find one now, can I? 2955. So I was maybe thinking of. See, it's an adjustable 3-terminal regulator capable of supplying more than 1.5 amps over an output voltage range of 1.25 to 32 volts. So they're using a variable resistor there, look, R2. So we can just get that bigger. (2,200 microfarads), 24 volts AC. Well, that's what we'd have, wouldn't it? If I use that 12 volt in series. (3055). I've definitely got some of those somewhere. That's the power supply caps. Where the hell have I put those to then? L1 is a 120 to 20 volt transformer. What's the verdict on that one? Rubbish? Emit the 2N3055 if the regulator can supply enough current on its own. Okay. So Rob is saying if you're going to use the 3055, hi Ganesh, how are you? So the LM317 is a good regulator. I mean, I like this idea of having a variable output. I mean, they've got a 24 volt transformer, which might be overkill, but then it'd be nice to use that transformer. So let's get some stuff wired up, otherwise nothing's going to happen. But how much current do I need? Only about an amp, really. I'm only going to really need an amp, aren't I? I'm not going to run. It's only really for transistor radios, Ninja. So we're looking at being able to build maybe more than one for each output, if you know what I mean. So really we want a 9 volt, a 12 volt and an 18 volt. All we want is one circuit. One circuit to do them all, really. Well, this might do it. Oh, don't tell me you're not going to fit in those holes. It will. So where are we? Hopefully you're on the bench with me. As I say, this is only a bit of messing about to see if we can do. I can't remember who it was. I think it was Tim. Tim was asking about it. Let's just turn that other light on, make it a bit brighter. No. Oh, of course, I've got the power supply turned off for the noise. That's a bit brighter. Yeah, I think it was Tim was asking. The 24 volt transformer is very common and relatively inexpensive due to them being made in such large quantities. Well, we're going to use this one because it is one that I've got here. We have got the smaller one we can use for smaller voltages. My wire's a little bit too big to go in there. I was going to use the spade connectors, but they're so tight on the terminals. Yeah, these are really, really tight. Suppose they would be better though, wouldn't they? Let's stick these on. It's not permanent then, is it? So as I say, that's the idea. It's just to build a power supply that we can use. Actually, that's going to be too big now, isn't it? Go over there. Bugger. Okay, we're going to have to forget the heat shrink because that won't go over. Just going to have to tape it up. Rubbish. I don't like crimp connectors particularly on anything, to be fair. I'd much rather solder it on, so I'm just going to heat it up and pull that off. Get off. Too slow, Graham. That's one. I'm not so worried about the outlet, but I don't really want 240 volts popping off on the bench while I'm working. I'm sure it'd be very amusing. Right, let's turn that on. So that means we can put our heat shrink back on now. Let's give that a little squeeze. That one. Hi Rich, how are you? That one's only good for 100 milliamps. So we're saying that was no good, Rich, or I've got the SMD one, which is in a much bigger package. Welcome, by the way, Rich. Hope you're all right. Right, okay, we've got some spade connectors on there for a minute. Yeah, I have got two versions of that, Rich. I've got the SMD package one, which is in a different encapsulation, but I don't know what that's able to do. So let's just open these up a little bit because they are really tight. Again, we want them fairly tight. We don't want them popping off, like I said. Cool. I'll tell you what, they ain't coming off in a hurry. I'm going to snap the blimmin' transformer off. These are so tight. But they are the right size for these terminals, but just a really tight fit. Okay. So that's my mains transformer. I'm just going to stick a bit of tape around that as well, just so as I don't catch my arm on it or something stupid. Because you know. Okay, safe, right. We are safe-ish. Let's get some other stuff off the bench. Send the circuit for 3055 regulator, no ICs needed. Okay. Hi Nigel, how are you? Thanks mate. So Rob sent a circuit for 3055 regulator, no ICs needed. Afternoon Aston, how are you mate? I thought I had my other camera on, but I obviously haven't. Now I have. I'm just getting stuff tidied up a bit here. I think what I'm going to do is on the outlet I'm just going to tack wires on. So I've got these jumper wires which we may need. Mustn't forget there. I don't like crimp connectors, I really don't. I've had bad experience of them in the past, popping out and causing issues. Whether it's because I've got a rubbish crimp tool, I don't know. Excuse me. I'm just trying to have a bit of a tidy up. Let's get things out of the way while we're messing with mains voltage. I don't want too many things knocking about on the bench. Metallic things, that is. Okay, so trying to think how to set this up then. How are we doing? Is it better to get it on the overhead camera? Maybe. Way out further than that. Right. Just make that a bit lighter. It seems a bit dark for some reason. There we go. Wet and windy. It's been the same here, Ashton. So Rich Bristol saying, fine for experimental purposes. You can also use a 7805 plus a Zener. 5 volt plus a 6.8 volt Zener will give you 12 volts ish. I've got a load of Zeners, so maybe we can have a look at that, Rich. As I say, I know nothing about this, people, so I'm really looking for help here. So my transformer, as we said, it's got a lot of glare on it at the moment. That's better. Let's go in a little bit closer. So it's got 12 0 12 0, so there's two parallel 12 volt windings on it. So I've got to try and get my head around this. To make it 24 volts output, I've got to go I've got to join the zeros together and the 12s together. I'm not 100% sure on that. This is where I'm getting out of my depth. Right, let's get some wire. We don't need anything too mental, I don't think. What we got? Theo, how you doing, mate? Didn't see you pop in. Buy Benji stuff. Benji seems to have more stuff for sale than anybody on the planet. Let's go with black and red as our positive and negative. So that's going to be sort of over to one side. Sure we've got enough length there, so there. I mean, this project board has got 3 different voltage inlets and a ground inlet, so it does give us a bit of scope. I've had this for years and years. I did give one of these away. I think it was not last Christmas, the Christmas before, that Georgia donated. I think that went over to France, actually. And the only person that hasn't got his prize from Christmas yet, I think, is Nathan with the RP30. So apologies, Nathan, if you are with us today watching. I think it was Nathan that won that one. But I cannot find my stapler at the moment. So let's solder some of these to the transformer. So we've got 4 outputs from the transformer, 2 12 volts and 2 0 volts. As long as I don't short the thing out. Do not want to short the secondary out on it. Which I may well do, because I don't really know what I'm doing, people. But it's good fun trying, isn't it? I don't tell you that ain't going to go through the holes either. Nothing wants to solder to this thing, does it? Okay. Just going to have to tin these, I think. Oh, of course, Michael, you haven't had the BFO yet. You are right. No, you are right. And the only reason you haven't had that is because I need to get and sort the schematics out for it, Michael, because they're when Manuel did it, he did it for a different version, and the schematic doesn't match the board, so I've just got to sort that out. But it is in a box there, Michael, ready to be done. So but thanks for reminding me that, because I had in the back of my head, knew I still had to do it, but it will be done. Coupled, that's what I'm after, Theo. 24 volts. Yeah, the BFO is sat over there. My built one plus a load of parts, an absolute load of parts, Michael. I've got far more parts than I need for that BFO. You've got a good case with BNC. A metal one, Michael? You did let me have your address, Michael, didn't you? Okay. There's our transformer, there's our outputs. So I've got to try and get my head around the wiring of that. So we'll be plugged into an isolation transformer as per usual. Stick that. No. So let's get that out of the way. Let's drop these back. Hey, Mike Atlantis. Yeah, no worries, Aston. Apologies that the poster DHL beat it up. I don't know, DHL have been okay so far, but hopefully it wasn't my packing job on it. I'm sure I packed it out with bits of polystyrene, etc. as well, but from what Aston said, the post people beat it up. Okay, so this is a little confusing. So I've got positive, and we'll go with this as a negative, although it's got voltage. It's not really an earth as such, is it? And for the time being, I'm just going to connect these two up to these terminals just so they're out of the way. So positive, negative, 240 volts. Let's plug it in. Let's get the multimeter up. If I get the multimeter in shot, we can have that as a picture-in-picture. So let's go 3 main camera. There we go. So power is on. Let's just monitor those two for a minute. As I say, I've got this on the Variac. It needs to be on AC because we're not regulated yet. So it shouldn't be pulling any current because it's not connected to anything. It's drawing 20 milliamps. So I suppose, yeah, it is a transformer. They do 40, 50 milliamps, 60 milliamps. 70 milliamps that's pulling. Rob is saying, does anyone know? Hang on, let's try to catch up here a bit. Hermes, yeah, that's a bit of a swear word, isn't it? Join the 2 middle terminals for 24 volts. So at the moment then we're 13.7 volts. 70 milliamps seems high, doesn't it? But I'm assuming that's correct. Let's move this drink out of the way now. Let's try the other side. That should be the same. Okay, so what you're saying is to join these two together. I see, so we're going in, out and in. Yeah, so that would mean that I'd have then 24 volts between. Hang on, no, I'm confused now. I see. Okay, right, I'm with you. So let's just take the voltage back down on that a minute. Can we just these fit in here? Okay, so if we join those two together, so that's linked them now. What we're saying is the two outer ones should now be 24 volts. Is that correct? Yeah, I think Chris said earlier that it'll be something like 36 volts. Or no, Chris said it'd be 36 volts after rectification. So let's wind it up again. 100 volts. $200 volts. So it's exactly the same current draw. So we got 27 volts now. That's more like it. Okay, so let's just reduce that back down a minute. Pop the power off for a second. So let's just remove that link and put in a better link. We'll take that one there out the board. So basically we can join these together, can't we? Or shall we link them? Let's link them because it'll help explain it better for me and anybody else that's following. As I say, if you're following this, then please be aware that I have no electronics training and I'm just experimenting with this. It's not it's not really meant to be an instructional video. Oh dear, let's get rid of that other camera a minute. $40-volt cap needed after the bridge, yeah. So you suggest a 470, Nick? So I think we'll put in... oh, why have I just cut that in half, you idiot? Oh, dear. Is there any holes in these? Usually they've got a hole in them. Yeah, okay. A bit safer. So what I'll do is I'll I'd have probably been better off with the should we clamp it on the actual? Got a wire come off there already. I don't tend to use this breadboard much. I tend to use, I've got one with a load of IC sockets stuck in there at the moment. I tend to use more. It's got to put a bit more solder on that one. None of these are really soldered on that well. The mains is disconnected now, by the way. It's not even crossing over. Okay, so let's use these two as our rails. So we want a link from here to here, and we've got this link already in here. So we use that as our positive, and we can use this one as our negative. So let's just get a link wire. and I'm just using this. I think I got this from CPC, although yeah, it's better to use these because they do fit in the boards quite nicely. Pre-bent. So what colour shall we use for that? We'll use white. Will that reach? No, it won't reach. It's typical, they haven't got a black one. Dear, oh dear. So we're going to have to use a red one. Okay, so we'll stick that in this rail. It's good to go. Positive, negative. So at the moment, this is sort of hooked up already. Whether that'll be any good, I'm not sure. We'll see in a minute. So next up, we need a bridge rectifier. I think these might be. Oh, what's that? A triac. Well, they will fit in the holes. To try and think if these are isolated. I'm pretty sure they run this way. So if I use this center one for the bridge rectifier, I'm going to have to cut that leg off because it's a bit longer. That denotes as the positive. So I've got this little bridge here. I'm sure you've all seen these. I could use just diodes, but it just makes it a bit more complicated. So you can see the middle two are the AC. The outer one with the little chamfered edges are positive, and the other side's a negative. So just snip that off so as it's level. I'm going to put that in here. The beauty of these boards is if you do find you're a bit stuck with space, will this go in? Come on. It went in just now. These leads are just a little bit too big. Hi Jeff, how are you? Electronic cribbage board. Just put the macros in the other. Oh, sounds nice. Just wondering if this is a little bit too too big for this board. So plan B is somewhere. I've got some solid wire. We just have to dead bug that one. They're just too big for the things to grab them. Let's have a look at this wire here. Yeah, that'll be fine. Tell you what, this is turning into a bit of a task, but you know. If I don't do it, I'll never learn, will I? It's all very well getting you guys to bail me out all the time, but I need to sort of try and learn for myself as well. Right, we've got some different colour wires here, so that's good. Right. So we use white and green for our AC. You built a 3 transistor radio. Hours of fun. Wrong way? Oh, wrong way for the bridge. Right, I see what you're saying. In the strip board. Yeah, I'm not sure which way they connect yet. I'll have to own that out in a minute. So it's a long time since I've used this board. So what it says, we need to be that way round, basically. Like that. Like that. Yeah? Easier to build on a piece of perf board. It will be, and I have got some perf board here, Doug, but by perf board you mean sort of this sort of stuff, don't you? But as I say, once we've got the circuit, then we can build it on one of those. But we need to make the circuit first to make sure it works. So it's going to be a bit Heath Robinson this, but we'll have a go. Let's come in a little bit. Yeah, that'll work. So what I'm doing is just really extending the legs of this bridge rectifier in order to make it fit the breadboard. How are we going to do this without burning everything? I don't really want to do it over the top of that, do I? Let's do this on the bench a minute. So I'm going to tack these on. Oi! It's gone walkabout. Okay. This ain't going to look pretty. It's not going to look pretty. But hopefully it'll get the job done. So I'm sure I'm right in saying that when you rectify AC, you get a voltage increase. So there's our new bridge rectifier. Okay. So let's just get my head around this thing and how it's laid out. Because you've got, what have we got? So we've got A to J. Now, are they connected that way or that way? Okay. So they're connected that way. If I can get the probes in. So if we use A as our starter, so that'll be our space them out a little bit. You know, a gap between them. Okay. Let's move these apart a bit. We don't want them shorting out on anything. What I'll do, I'll just bend that back on itself so it rests on the board. So that's our dead bug style. Let's get that out of the way. So let's go back to our jumpers. So we need a connection from the AC to the two middle pins, which are, just move that over, the white and the green. So we should be able to go shorter with our links now. So that's our positive. That needs to go to, say, there. Not quite big enough. That one in. Get in there, little sod. Okay, that's one. Let's just go a little bit further up. Okay. I think we're good. So we've got the AC coming into the bottom so far here. So we've got the DC positive and negative on these two here. It's going to be a little bit tight there. Probably need to maybe shove that over that way. Move that one up a peg. You can build yourself into the corner with these things. Hopefully that's not too close for you. Let's just zoom out a little bit. Right. Let's take a call from work. What have you missed? Not a lot. We're getting there, Ninja. We're getting there. Okay. So let's get all this junk off the bench again. Sure everything's out the way. Let's get the multimeter in. These just clip on here. One on there, and that one on there, and we can measure our voltage. We'll pull the plug on this. It gives it a fair old surge when this comes on to start with. So we're now on DC because we're now rectified. $120, $150, $180. So let's go back a bit, just overshot. About 240 volts there. So it's actually giving us 24 volts on the output. Look, That's not bad, is it? Etch my own Veriboard. So it's still drawing our 70 milliamps, but we now have DC, 24 volts, unregulated. So by unregulated, it just means if I turn the voltage down, then the voltage goes down there. If I turn it up, then the voltage is going to go, I mean, this will go up to 260 volts. Look. So it's got a little bit of an overwind, I believe, on the transformer of the Variac. So basically 24 volts rectified, full wave bridge rectifier. So what next then? Where do we go from here? So you need a cap on that to see the true DC. So if we look at this circuit, perhaps that uses quite a big cap. This one, hopefully you can see that in the screen. Yeah, this one uses a 2200 microfarad if we go with this LM317. But what we're saying is we can actually eliminate this piece altogether. So do we need to still go 2200, or can we cut that back down? R2, I don't know what the value of R2 is. The potentiometer. Let's have a look. R2 is a 5K potentiometer. So I'm not sure if I've got one of those, but I might have. So let's turn the power right back down to nothing. $2,200 is a bit high. Do you want 1,000 or 470? When is production starting? You never know. So 2,200 is a bit high. 1,000, or we're going to go back to 470. I've got stacks of thousands here, so we can stick 1,000 in. Say I've got stacks of thousands, and now I can't find them. I did have a bag of thousands here somewhere because I gave a lot of them away. Oh well, I've got plenty of 1,000 microfarad caps anyway. Let's dig one out. So 35 volts at 1,000, or maybe a bit higher than 35. 35 is probably as big as I've got. What's in here? Yeah, make sure it's the right way round. You stick with 470. Let's have a look what I've got. 470. I need to check the voltages on them. What are these? 470, 25 volts. No good. I've got 470 at 35 volts. What are these? 2700s. 35 volts is about all I can do on that. Not something I keep a lot of. Yeah, 50 volts would be better, Doug is saying. What else have we got here? 33. Let's have a look. I'm going to go deep. I'm going to go deep into my archives of parts. Let's get this one out, which doesn't see the light of day very often. I've got any higher value ones in here. 470, 35. I've got some pulls here, 40 volts. 25. I got a 40 volt one there, but it's old. That's a sound going deep now. Just check what axials I've got here a minute. A bit lumpy. I've got 470 at 40 volt axials. So I mean this one's probably as good as any. Let's just check it on the SR meter first. Let's say it is an old cap. Is good. Okay. Let's go back to the overhead cam. Just going to check this one a minute. As I say, it is something I've pulled from somewhere. Let me tell how old it is because I wouldn't normally use a pulled cap. I've taken it out of something. Okay. It's reading 477 and 0.11 ohms ESR, so that's fine. No issues there. So that's got to go across a positive and negative. So again, I can't. I haven't got enough leg space for that. Let's get my axial out. Let's get an axial out. These are 40 volts. These are 40 volts. They give us a lot more leg room. So negative is this side. Tell me these won't fit in the hole now. Yes, they will. Okay. So we're going to need to come back one because we've got no output else. Let me go back another one just in case. And we'll go in there. That's a bit of a botch, that, but it's in there. Right, let's try that then. So let's now hook on to the cap. Let's see what we've got. So definitely the right way round. This side's to ground, this side is to the positive. Okay, so let's wind it up again. Okay, 100 volts. Coming up to 200 volts, how are we doing? And there we go, full mains, 36.45. Just sort of moving about a bit, isn't it? I suppose that's just the mains fluctuation. Because again, we're not regulated yet, are we? We're rectified but not regulated. That's going to be a bit high for the 317, is it? Strange, isn't it? Because it does say in that circuit for a 24 volt AC transformer, which this is, but I suppose this they're looking at a 120 volt transformer, I suppose. Yeah, see, they're using these higher ones, aren't they? Okay. All right. So maybe this this won't be suitable for that LM317 I've got. I mean, let's just quickly look at the ratings of this. It says input to output voltage difference 40 volts. 40 volts differential. Does it say what the maximum? I mean, surely to get 37 volts on the output, you need higher than 37 volts on the input, don't you? I see you retracted that RV. Okay, I'm not really sure about this now. You've put a doubt in my mind there, Doug. The 317T can be put on a heat sink. See, I have got the this version, but it doesn't. It gives the same ratings for both, really. Input to output voltage differential. Yeah. Exactly, Richard. It's going to do 37. So your data sheet says 35 volt max. There's 36.7 there at the moment. I mean, I can pull it back on the variac, to be honest, but that's defeating the object, isn't it? Really. So say I have got 7805 here as well, but I think that's the same package. Yeah, so I've got some 7805 LO5As and 79 LO5As. But I say that's 5 volts, isn't it? I suppose, I mean, we could we stick a resistor in there to drop the voltage? Yeah, I mean, this says input to output voltage differential. So if you had, yeah, is an LED across the cap going to do much? It's strange, it doesn't give a maximum maximum voltage, does it? How are we doing it? What screen am I on? Oh, you are with me. Yeah, see, this all shows one of these ones with a heat sink on it, doesn't it? I haven't got one of those. I'm sure I haven't. I'm just going to check my components a minute. So let's go back to the overhead camera. Let's have a quick look, see what I've got. All these random flies in here trying to bite me again. Oh, I've got an LM3317T. Hang on, I have. Box number 7, apparently. Okay. Oh. Well, what do you know? I just haven't listed it as a voltage regulator. That'll do it. Be happy with that? So let me just have a quick look at this and see if I can find a data sheet for it. So I've obviously bought these in for something as well. LM317T3. LM317T3. M317T3. Oh, TS. Okay. 2.2 amp that is. Still 40 volts input. So that's a bit of a beefier device. So I've got it on the TO220 package. So we've got 4 volts of headroom. that's a bit better, isn't it? Maximum ratings. Input, output, adjust. Okay, I need that in a minute then. .40 volts maximum, output current internally limited. See if we've got a circuit for this. Come on. There we go. Basic adjustable regulator. Voltage regulator with protection diodes. Yeah, see, that's not showing the full works. I mean, what was that one there then? No, that's that one. So we could be going back to this, but leaving out the 3055 R2. We need a 5K. I mean, I've got a 5K log potentiometer, I think. I'm just wondering if I can get one of these trimmers, if I've got 5k one of these, but I don't think I have. Would 10k be alright, do you think? So I've got these type of little resistors. I don't think I've got a 5k, I think they're all... What's that? 10k. 10, 22. Oh, 5k. Here we go. I have got a 5k. It's getting complex. The further we go, the more complex it gets. Let's just pop the power off a minute. I take it that's not getting warm. Nah, stone cold. There's no... I don't know that I've got a heatsink for that package, to be honest. Heatsinks is not something I've got a lot of. I could put a heatsink on it, but again, we're not going to run this for a massive amount of time. So I've got a 5k variable resistor. Right, so where do we go then? Go for it, Rich. Just go for it. Let's get myself back to this then. So after that, we've got our input for the... So the positive side goes to the input of our LM317. And the input of this thing is... is that pin there, so that's got to go to the positive side of that cap, so that's there. We're going to have a bit of a stretch, aren't we, to get to so I might have to do this with some jumpers. So if I do that in there, go on, come on, surely you're going to fit in. What? This is the problem with this, isn't it? It doesn't like it at all. You think that would fit in there, wouldn't you? They're just too big. Or is it because they're square pins and not round? Right, so we're going to have to put some more bodge wires in. It's defeating the object of building it on a breadboard, isn't it, really? Oh well. Not to worry. It is what it is. It's better to do it on this, I think, than trying to work out how to put it onto a strip board. Cutters. Plenty of wire here. We got plenty of wire. How are we doing for time? I've lost my clock for some reason. That's fallen down the back here. Ah. Ooh. Ooh, sir. Should be finished about 5:30, really. But just as we're getting a bit interested, isn't it? Just as it's getting interesting. Come on. As I say, probably this transformer's not quite what it ought to be. But we've got to go with what we got. The idea is to try and build this out of stuff I've got here rather than ordering bits in and trying to do it that way. A junk box build. Shouldn't do it over here really, let's just do it out over this bench. Okay. Just soldering these wires on a minute. I'm just out of shot because I don't want to melt my breadboard. I'm trying to do this with my fingers and I'm nicely burning them. So input, output, we're going to go with green. So output, and then our adjustable one will be white. If I can get the thing soldered on. Oh, I did have it just nice. The thing moved. Right. It's not pretty, but it's there. So again, another dead bug style component. Oh, and one of my legs has just come off. Look, that wasn't soldered on very well, was it? Come on, Graham, sort yourself out here. What's going on with that? Well, so I only just tacked them on, really. Right, that should be better. Got flux on my fingers. Okay, so let's just pop that in here. input. Output. And adjustable. Right, okay. Let's tidy that up a little. Let's just tap that one on. It's not very good, that middle one. Better. Regulator in. Input, output, adjust. So input is going to be linked to that one. Double size there. That's our input. Don't want to go in there, does it? Should do, because it's the right size. Oh, that's not very good for some reason. The joys of breadboarding. There we go. So that's our input straight off of the cap. Also joining the input from there. So the middle one is our output. So where are we going with our output? What camera are you on here? I think we're okay. Can you see me? I think so. So our output is literally our output. So we've got to have so the output has got a resistor on it. R1 is 180, 180 ohms. Have we got a 180? I'm sure we have somewhere. 220, 180. Here we go. 180, half a watt. I think he said he uses a watt on this one. Half a watt. No, that's okay. So I've got half a watt. That's fine. So according to that, which one did I say is the output? The green one, didn't I? So green wire is the output, which is there. So that's got a resistor on that, which goes to, or between the adjustable and the output. So that goes between those two, like that, according to that. Actually, I can pop that in behind, can't I? So I'm looking at this this diagram again. So I put R1 in, which is straight across the adjustable part and the output. R is 180. R2 is going to be tricky. So that also connects to the adjustable point, which I believe is the white one in my case. So this is the pin out, so the adjustable is the white wire. Just about enough room to do that. So I put that in there. So one side of that goes to R1 and the adjustment point. The other side goes to ground, and the wiper joins the other side to the output via a 47 microfarad cap. Okay, so let's get this right. So that's our positive and negative there. So one side goes to ground. Which is the negative side of our cap over here. So we should be able to just link that across. I'm sure there's an easier way to link it, but I just seem to be doing everything the hard way here. So that's linking that one. Okay, so if we use that as our negative, I take it doesn't matter which way round this goes, it's only a variable resistor end of the day, isn't it? These are specially made for breadboards, but this is, gosh, making it hard work. Okay, so that's going to be our input. So this is that's our ground. Our input to the adjustable side. It's going to be easier to do it the other way around, isn't it? So let's move it to there. So going in here, out there, and our center one there. Okay, where's our input coming from then? It's coming from R1 and the adjustment point, which is white. So we're going to need to do another link over the top, I think, for that one, just to make it easier for me. Okay, that's those two. The wiper. And we need a 47 microfarad. Again, we need to be apologies, I'm ignoring the chat for a second. 47, we need to probably be up around the higher voltage end of the scale, don't we? 47. I've got 100 volts 47 here somewhere. That should do it. Yeah, a bit random. So The wiper goes to ground as well. So let me think which way round this is. It's the negative goes to the wiper. The other side goes to the other side of R1. Which is on the green wire, which is the centre. So I'm talking to myself as well now. Output. Yeah, okay. So that goes across there. But that is also joined to ground as well. I haven't got enough room. It's all getting a bit compact now, isn't it? What screen are you on? Yeah, you're with me. You are with me. Just get the chat up a minute. The cap is charged to peak. It needs a load to bring it down a little. Try. The cap is charged to peak. The rectifier cap. 4K7. What are you saying there? Hi Daniel, how are you? Hi Paddy. I'm not really with you. 4K7 where, Zedex? You're saying R1? Just seen this. You only just seen it. So that needs to go to ground as well. Shame we haven't got a few more holes in there. Let's cut some more bits of wire off. I've got some black here somewhere. There we are. Are you saying increase the value of the rectifier cap, Harvey? So that needs to be connected to ground. And that needs to be connected to ground as well. And this is a bit of a stretch. Oh my god, we're building ourselves into a corner here. I don't want to be shorting stuff out here. That's not going to be good there, is it? It's going to short that out. Let's put a little bit of sleeving on that. Sleeving? What's sleeving? So say this is the diagram I'm following at present. And I think we're nearly there. Cruncher will be sorting on my tea out very shortly. Just putting a bit of heat shrink sleeving on these just to stop this cap shorting out because it's some sort of splayed across everything here. Okay. That's better. Okay.
No, you're gonna sit. Sit down. Sit.
So let's just cut a couple bits of wire off then for our input and output. I think we're there, aren't we? I'm still not sure what Harvey's saying about the rectifier cap. The cap is charged to peak. It needs a load to bring it down a little. Try 4K7. Are you saying to put a resistor in parallel across it? Put a resistor across it, Harvey. You need to let me know before I stick some power on the thing. Okay, so that's our ground. So our output for this whole circuit is R1. Let's go back to my picture. So the output is the middle pin, which is green. So that should be our output there. Right. It goes nothing then. I've heard of the Big Bang Theory, but I need to get everything away from the power supply. Let's stick that let's stick that somewhere in the middle. I think we're ready. We are ready to rumble. So if I connect to that, let's just get you back, make sure I'm on the right camera. That should be my output, and this is my negative here on this cap. Here it goes then. It's a bit of a Heath Robinson job, isn't it? It's Let's have a look then. Let's start winding it up. See if any fire comes from anywhere. Any smoke, excessive current draw. £100, and we got 13 volts out. Winding her up. £200, and it looks to be regulating in nicely. Okay, 240 volts, and we've got 19 volts there. Let's have a twiddle. $18 volts. Regulator's not getting hot. $12. Stone cold still. Obviously no load on this, mind you. Still stone cold. So we've got no load on it, but that actually works. That actually works. Trying to think how we could put a quick load on it, because I will have to go very shortly, but just trying to think whether we could croc clip a radio up to it, perhaps. What have I got? Is the chat frozen, or were you all absolutely amazed that this works? Let me go and see if I can find a 9-volt radio emitter to stick on it. Something that works. This is the key. Do that little rambler that I had. A little test. Here. Right, anyway, we're going to try it with this one. So Let's just do a bit of camera adjustment now then. Let's get this camera in here for a sec. Oh no. No, we want that other camera in, don't we, really? We want that in to monitor the voltage, really. So let's stick that in number... There we go. Okay. So this is the little Rambler 2 that we restored over Christmas. So let's croc clip it up. Now we've got a red and a blue. I've got to assume that the red is negative. Let's just get a battery just to be 100% sure. I'm pretty sure. Sorry, the red is positive, not negative. Cracking up, man. Find a battery when you want one. When you don't want one, there's hundreds of them, isn't there? Okay, yeah, that is definitely positive. Negative there. Okay, it's a bit Heath Robinson, but input. You'd be happier if you drop the input to the bridge down to 12 volts. The input is too high for 9 volts. Okay. Let's just turn it off for a second. Get to grips with what you're saying there. Why is the input too high for 12 volts when we've got a regulated output? I'm not really sure there. I mean, I can do that easily enough, can't I? Because I can just... Let's do that then. Let's link that one and that one. Let's take those two out then. Let's link that one with that one. Okay, so I'm just running now on the 12 volts. So let's wind it up again then. I think that's right. Okay, so we're on 12 volts input now. Is that okay? We happy now? Are we happy now? So if you can see, I'm sure you can see what I've done there. So I've just taken out that side of it altogether. So I'm just running off the 12 volt terminals now of this one. So it's still at 9 volts. Here it goes then. It's not even warm, to be honest.
I'll let the owner answer that, because when we first met, she seemed a bit thoughtful. But yeah, do you want to take over, Anne?
Well, I think you do it down and investors.
There's no heat anywhere on it. Whoa. I think we've cracked it.
One of a lot of things that probably weren't the best. I mean, Ronnie, you're the first to say, you know, you love food.
I mean, that's a pretty stable 9 volts, isn't it?
Things like that, but I think portion size was a big thing with Ronnie as well. Just feeling full, knowing what to eat in order to maximise performance. So we've been on such a huge kind of food journey, and now Ronnie's one of the most intuitive eaters I know. So his journey's been big, hasn't it, Ronnie?
Yeah, no, exactly. Like I said, you know, my downfall was that portion size. I remember I said to Ronnie, I said,
cracked it.
Yeah, they are. I said, I did them away the other day, so you only match that.
You want an ammeter as well. You want it all, don't you? This has got to be the last test. Let's chuck an ammeter in line. DC amps. I think that's right. Let's try that. Oh damn, pull the bloody wire out now. Output is the green, isn't it? Just let me double check that. So I've just pulled the wire. Yeah. Output is the green. Yeah, no, you are right, Ninja. You are right, definitely. And I was thinking about doing that just now. I was just thinking at the time, that was all. Just being time sensitive. What am I doing here now? I need that in line, don't I? So I need one on there. I need the other one. Hopefully that's right. You know, you can just see the amps, but now let's just pull this camera out a bit. What are we doing here? I don't really trust this meter. Milliamps, that is correct. But we're not getting any voltage on that now. So let's go in there, in there, that's right. Right, okay. So hopefully no. Yeah, that should be right. Milliamps. What's going on with this meter here then? I don't trust this meter, to be fair. It might be totally dead on amps. It might be absolutely dead. Ninja, thank you, mate. You're fasting? Cheers, mate. Yeah, you're right. You're right there, Doug.
So it's like understand what's going on in your head. If you're about to react to, let's say, a binge, you really have to stop and say in that moment, am I feeling low? And this is actually going ahead and teaching you this way. This is going to help you
Once you've learned one coding language, learning another one does not become difficult because it's all based on conditional logic.
It doesn't seem to be any hum on it. It sounds fine to me.
If you eat your dinner, you can put it. There you go. There's an if statement. That's conditional logic, and it's one of the foundations of all coding. So these things are very straightforward.
See, I'm not sure why we're not measuring milliamps. We should measure milliamps in there, really. But it's not. Stupid meter. Oh well. It's measuring it in there.
I believe that all, most employment opportunities are going to come in some form from the technology sector, and an ability to code really puts you at the front of the queue of the employer. The manual tasks that we take for granted. Really,
So it's 20-30 milliamps, which is about right, isn't it?
For another debate, but let's just take vehicles for example. Automated vehicles, or people that would be driving cars or would be involved in other elements of the car industry would suddenly be involved perhaps more in the traffic system and traffic management, which would all be done through a level of coding. Mechanics will be fixing electric cars, which are essentially batteries with wheels.
So I turn it up.
The things you need to fix are the coding that runs under the hood.
Where's the engine? God! Oh dear.
That's just taking, transport as an idea, but there are so many other areas where this is happening in agriculture and all, food production, in everything. It's all going to.
It's not even lukewarm, the regulator.
It makes things more efficient. It makes things more globally friendly.
It could be, Doug.
As in every industrial revolution, there is a loss of certain jobs, but creation.
There you are. Well, we have a very crudely put together power supply. Now I suppose with the transformer that I've got there, I would have to probably, I could work it out and have some switching, I suppose, in a case to switch it between the 12 volts or the 24 volts range for the bigger radios perhaps, but that is not even lukewarm. It's not, so there you go. So let's go to the main cam and cube that. Let's take the picture-in-picture off. Let's pinch this camera back because I'm going to need to call it a day now. But that was a very useful experiment for me anyway, for sure. Now is this packed up again? This camera's got a blimmin' mind of its own, I'll tell you. Where's the Brio? Ah, no, the streams. So I don't know if you can still hear me, but it's all frozen up here, so I'm going to have to just restart a minute. Because I've moved that blimmin' camera again. Okay, I should be back. Apologies. This webcam's a bit of a pain in the bum, and I've got that big light in the shot now as well. So it's probably blinding you. Oh dear. But I think we're back. If you want 1 amp, so increase the input cap to a higher value and be aware of the cap ripple current. That's it, people. Have I got an OnlyFans account? Welcome, George. Right at the end. Oh dear. So I've just signed, but unfortunately the camera froze, and once if I knock the connection for this webcam, it takes the whole stream out. So unfortunately that's what it did. So Rob is saying with that transformer you could use the other winding to give -9 volts, so you get 18 volts using both. Yeah, I think I'm with you, Rob. But to be fair, I'm happy with that. I've built a power supply and it's working for 9 volts. I think if I wanted the 12 volts and well, that would do 12 as well, I suppose, wouldn't it? That would do 12 with the 12 volt input, would it, or not? It probably would want the higher output for 12, wouldn't it? But there you are. That's it then for now, people. I hope we've enjoyed that today. I say it's a bit of a scrabble to get it all working right, and microphone issues and a camera not working and all sorts of other things. I don't know what's happened to that one. Actually, has it come back now? No, it's not. So I've lost lots of cameras, but you know, we got there in the end. So cheers everybody. Thanks for the super chat, Ninja, and I'll catch you all on Sunday, and we'll be starting something different on Sunday. So good stuff. Hope that was of interest to you. And say it's something to be experimented a little bit more with, and maybe look at a different transformer, slightly lower value one, and we'll have a power supply that will be good for all of it then, really. So bye everyone, and catch you all soon.